the regression coefficient, B. The regression coefficient is inside of another formula, and that formula is called the regression equation. So only one variable there for us. And so it's just simply the straight line function y equals a plus b is. Well, the central consistency in here is going to be this regression coefficient. And it's going to be useful to show us the relationship of the extent to which x and y covariate together. And that's what these tests of correlation are all about. What is the extent to which x and y, independent variables and dependent variables, are covariating together? Okay? So we saw that with the same data when we were using correlation. And we got a negative 0.75, I think it was. Reflecting the fact that as you go up on this variable, there's no, as we suspected, that you would go up on this variable. The more education you get, and the more income you're making, dollars per hour. But that was not very well demonstrated in that data that we had for correlation, because as this data started going up on education 2 years as opposed to 1 year, sure enough, for going from 1 year to 2 years of education, we in fact went down. We went from $8 an hour to $7 an hour. That's going in reverse, what we thought we were going to do. That's why we came up with the negative, because the negative relationship is going up on one variable and coming down on the other variable. That's exactly what happened on this first piece of these first two people. Now when we went from 2 years to 3 years, we in fact did. So there was some indication that it could go up. We went from $7 an hour back up to $8 an hour. This $8 an hour person is the same 1 year. So there's no consistent pattern here that the more education you get, the more you're going to make like we thought. In fact, the data is more so showing, as it's reflected in the coefficient of negative 0.75, and the higher this thing, higher the years of education, the less the dollars you're making per hour. In fact, look, you go from 3 years of education to having 4 years of education. Look what you did in terms of dollars per hour. You went from $8 an hour down to $4 an hour. So that's really going in reverse. So all correlation is doing is trying to capture, as you move from one piece of data to the next on one of those variables, are you going in the same direction on the dependent variable? Are you going up with it or are you coming down? Okay. Regression is going to be doing somewhat the same thing. It's trying to talk about the extent. Well, R and B are trying to talk about the extent to which changes in one variable are related to changes in the other. B, on the other hand, has a different formula that we'll see in just a moment. Okay? So we want to talk about the B, or the regression coefficient, in the context of the equation that it comes from, and that is the regression equation. This is a familiar equation for you, probably from high school algebra. It's a straight line function. In fact, we might just step back here and talk about the importance of regression. Regression is, I would say, that most of what we know in terms of our textbooks is coming from regression type problems. In terms of producing a knowledge that we have. Take this one in terms of the more education, the more income you make. This probably, in fact, that's true. Here's what we know generally, that it is true that as you increase on education, you will, in fact, increase on income. So as you go out here on education, get more and more, you're going to tend to go have higher income. So go out this much, come out this much, go out this much, come out this much. So that line is suggesting that is in fact what happens. But when you narrow it down, let's say, if you look at, let's take African Americans for example. This is less true. Probably a very significant fact that we need to consider in terms of when we ask the question why you're not doing well. When you can't produce this thing that we think is common in this society. So here we're looking at the, let's just leave African Americans. And you have this kind of relationship going on between education and income. There's a slight relationship between how much education you get and how much you make. But this is what's going on in, white America. So that you're seeing this opportunity provided by education. It has implications in terms of real life phenomena, in terms of trying to understand it. If you drop out rates, if you can't see this, then what's the purpose? So what I'm saying to class is that the use of these statistics for real life dramas that are happening in our lives is staring us in the face. And so this is especially true for the regression equation in terms of being able to show these kinds of relationships. So we could draw this kind of a line for the regression equation in usual and similar patterns in terms of showing statistics. Not only in terms of what we know about the world, in terms of using regression to reflect what's going on in the world, the lack of opportunity and its implications for dropout rates, criminal behavior, but in terms of practice. For example, let's say you got a job, for those of you in the criminology of administration of justice, let's say you got a job in a police department. So, those of you in this field, I know that there's where's that statistic? There's like 20, every second in this country, there are 20 or 30 burglaries taking place in Crossfire. Some ridiculous number. And there is no way in the world that we have the resources in our police departments to be able to actually investigate all those crimes, those burglaries. So many times we have research departments in a police department that says, okay, we'll go after the crimes. We'll investigate the crimes that we have the chance to solve. Okay. Many times it's a regression equation that does that. So in the regression equation, there are variables in there that we think will produce, let's say, we think a variable is the likely percentage of the time the crime gets solved. That would be our variable. One of the variables that might go there would be the number of technology implements in the crime scene. Was there a camera? Was there some type of video? The number of these technological innovations that are at the crime scene, which one is solved. Or maybe it's the number of witnesses. We know that the more witnesses there are at the crime scene, the more likely to get solved. Now that's a simple case, and that's all we have time to do in this class. Let's just take a simple regression equation. That's one independent variable. Most realistic representation of regression, for example, in the next course that you take, take a course on especially for regression, you're going to move from this into multiple regression where there's several variables. So X1 might be the number of technological innovations at the crime scene, number of cameras. Second regression coefficient might be for the number of witnesses. The third might be whether or not the crime is placed in the day or night. You know that there is a relationship between whether or not the crime is placed during the day or at night in terms of whether it gets solved or not. There are variables that we know that determine whether or not a crime is successfully investigated or solved. And so this is multiple regression. Well, there's several regression because we have multiple different variables here. This is beyond our scope of this class. Not ready for this, but we are ready for the basic elementary statistics of the simple regression equation. And that's just crime class. That's just one practical use of regression. You go to many times in terms of school, when I'm going to get into the school, it looks like this. So you send in 3 letters of reference. You send in your SAT scores. You send in your GPA scores. So there's usually a committee who's going to make a decision about whether or not you get accepted into that particular undergraduate program. So why might be whether or not we accept it or not accept your application to come to our graduate school, to come to our undergraduate school. One of those variables might be person's GPA. We know there are certain GPAs that are contributed to successful completion of that degree, while others are not. SATs are predicted. And they generally rank these letters of reference, letters of recommendation that you get. And so they use plug those things into the formula to make the decision as to whether or not to accept. Or a bank account, you're applying for a loan, or we're going to lend you the money or not, based on what is your income. Do you have a job? Those variables that they all be related to whether or not you repay your bill. The thing I'm trying to say to you guys is regression, whether you want it or not, is in our lives. In terms of decisions that are made about us, for us, and that in terms of how we develop knowledge around us. So it's important for us to at least have some understanding of the basic form of this regression, simple regression. So, why if we wanted to see how to set this up in terms of this equation, usually we put a half of the distance to predict y. We want to predict some value of y if we know a person's x. So, in the data that we have here, we would like to predict a person's income if we know their education. So that would be a piece of it here. So, simple regression is for prediction. What we predict y to be if x is some value. And I just threw it, what if we wanted to predict a person's education, according to our data, if a person had 10 years of education, or we could do something that we already have here. Because here, the concept of error, we could be wrong. I don't want to get too far into this right now. So you could put a value here for something you already have observed, or put a value into something, maybe a 6 year. A person who had 6 years of education will predict over their income. So regression is primarily going to be for prediction. And our problem is to predict a person's income, how much they're making per hour, if they have 1 year of education. That's our problem. Okay? So let's work on it. Coming into this formula, the first thing is the regression coefficient. The regression coefficient. Okay? So we need to work that. The regression coefficient looks very much, the formula for it looks very much like the Pearson's R. If you remember R yesterday, it was a ratio of the sum of the covariance between x, y. N times the sum of x, y minus the sum of x times the sum of y. Well, that's the same numerator as the regression. They have the same numerator. So both of them are going to be talking about a ratio of covariance. The top number is telling you how the two numbers covary together. Now, what is the extent to which changes in one variable is reflecting changes in another variable. Go up on 1 unit on one variable, go up on 1 unit on another variable. Go up on 1 unit on one variable, go up half each on the second variable. What is the extent? The covariance. This formula is designed to capture that. And it does it in correlation as well as in regression. Now where they differ is in the denominator. In regression last time it was the ratio of covariance, two variants in X and variance in Y. So we have like the sum of X squared minus the sum of X squared. And we do the same thing with Y. N times the sum of Y squared minus the sum of Y squared. Now we get the radical. When you do it this way, you're going to standardize it. You're going to get a value, a number, as I said, it's going to fall somewhere between 0 and 1. The positive and sort of standard. It can't be, there's no such thing as getting a correlation over 1. But sometimes we would like to have a number over 1. And we can do that by this thing called the regression coefficient. Forget about the variance in the Y and take it from another radical and just do this. And now we have the regression coefficient. And that's the formula you see here. So they're very similar. Numerator is the same, but the denominator is just the variance in X, not the variance in X and Y. So the regression coefficient is a ratio of the covariance between X and Y to the variance in X. Okay? Alright. So that's why they're together there. They're not the same, but they're very close. They're close. Alright, so we want to apply this formula to our data. So given this data, the same data that we had for working the correlation. So, n times the sum of x, y, well, we need x, y. So, 1 times 8, 7, 14, we have 3.4, nothing to do going on here. The same thing in correlation. We need the sum of that, that's 62. So, n is 4. There are 4 people, 1, 2, 3, 4. Got a piece of information on the 4 people. Got their education and their income. So, n is 4. And the sum of the x squared is, the sum of the x times y is 62. So 4 times 62 minus the sum of x. Well, the sum of x is 10. Okay. 4 plus 3 minus 10. Times the sum of y. So the sum of y adds up to 27. So there's the diversion. So, denominator is going to be half correlation n, again is 4. Now we need the sum of the x's squared, so just like in the last column, we square the x. So 1 times 1 is 1, 2 is 4, 3 times 3 is 9, 4 times 4 is 16. The sum of that is 30. So 4 times 30, 4 n times the sum of the x squared, 4 times 30. Minus the sum of x in parentheses. And of course, that's 10. And squared. So that's the regression coefficient we're going to set up for.
Do you have the equation for the simple?
So, 10 times 27 is 270. Subtract 270 from 4 times 62, which is
regression equation of this.
248, and that's the negative 22. And the denominator, 10 times 10 is 100. Subtract from 4 times 30, which is 120. So negative 22 over 20. 20 into it. Negative 22 is a negative 1.10. That's my regression coefficient. A negative 1.10. So we're going to do a problem in terms of calculating. Now, what does that mean? What does that tell you? Because this is the simple statistic that we're trying to work here in terms of the extent to which one variable is related to another. So it has the following interpretation. There is an average decrease in y of 1.10 units for each unit increase in x. Okay? Every time you take x up by 1 unit, now units in x is years of education, every additional year of education, you are going to decrease income by 1.10 units on y. The units on y are dollars per hour. $1 an hour, $2 an hour. Well, $1.10, 1.10 is $1.10. $1.10, a tenth of another dollar is $1.10. So what this thing is saying is, for each additional year of education you get, your income is going to go down by $1.10 an hour. So it's an average of class, and so it doesn't happen every time. And that's what you want to be careful about when I ask you on the exam, what you got to regression look at such and such, what does it mean? Most people lose points, lose a couple of points on this one because it is an average. Just because you get an additional year education doesn't mean that you automatically, it's not saying you're going to lose $1.10. It's saying that on average, some people use more or less, you don't change it all, but the average of all of them is the loss of $1.10. Now the question might be why decrease? It's decreased because this thing is negative. This thing could have been positive. And if it was positive, it would be more intuitive. Because intuitively, we would like to think that the more education you get, the more income you make. So every time we would like to think that every year of education you get, you would be increasing your income on average by $1.10 an hour. This data that I pointed out to you was chosen purposefully because it can be used didactically to show you to show you what we're after in correlation. The data can go contrary to what you think it should be. And that's what's happening here. Okay? Any questions so far in terms of this regression correlation? This is the statistic that is telling you the extent to which one variable x is related to a dependent variable, second variable y. So, if on the exam there's a question saying what statistic produces the result that each additional year of education yielded the fact that on average you wanted 2 fewer kids. The statistic you're going to say would be equal regression coefficient. That's what produces that kind of a line. That's very good.
Can you say the first piece that life exists as a result of
Well, I'll come back to that one, but I'm just trying to bring another example of this. If the finding was, the question was, what statistic produced the finding that there is on average a decrease in y of 1.10 with each increase of 1 unit in x? The regression coefficient. So all we did was think of another example and said what statistic produced the finding that but basically, what statistic produced the finding that every additional year of education that you got, there was a decrease in the number of children that you want So the same variable right there, right? The variable and what that coefficient is telling. Well, that's part of the regression equation. That's the one value that we need in this equation. In order to do what we're after here, we, as make this prediction of what the person's income would be if they had a year of education. There's a couple of other parameters in here. One of which is called it has different names when you read about it in your text. I think it's called the intercept, but it's arithmetically, let's just write it out. It's A is equal to intercept. This is more geometrical language here, but that's telling you the value of y when x equals 0. So A is going to tell you what is the dollars per hour that a person is making at 0 years of education. When you're at 0 on x, what is the value on it's called the intercept because you couldn't plot this data. Let's just plot the data here, x and y. So 1, 2, 3, 4, 5. This is years of education. And this is income, dollars per hour. 1, 2, 3, 4, 5. So, in the first person, if they had a year's worth of education, one, and they had $8 an hour, 6, 7, 8. So, the first person had 1 year of education, they had $8 an hour. Next person had 2 years of education, they were making $7 an hour. Next person had 3 years of education, they were making $8 an hour. And the next person had 4 years of education, and they were making $4 an hour. So, now the regression equation. Trying to run a line. This is the whole block. This is what's called a regression line that minimizes the distance between those points, the line that I run in. And I could use this formula when I get it developed to draw a line. I need 2 points. If you draw a line, the geometry line is not good. It takes 2 points to draw a line. And so I can get this equation and put in 1, if you want to, then put in another line again that I have 2 points, I can draw a line. So I can draw a line. That line is designed to minimize the distance between these points and that line. The line is this line. I'm going to put the dotted line here. Let's say that I do a straight edge. But it looks like it's crossing around 9, so that's the intercept. Now this is a geometric discussion. This is the one your author gives you on the intercept. It's called the y-intercept. That's why it's called the y-intercept. Use the y-axis. This is where the regression line intercepts that axis. Now we're going to calculate, you're going to see the value is going to be 9 something. But arithmetically, you can see that it is on this line, that would be the value of x, the value of y when x is 0. So if you're 0 on x, that would be the value of y. And that's our definition. Okay? So let's do the formula for it is the mean of y, or A is equal to mean of y minus b times the mean of x. Alright, the mean of y, 27 is the mean because the sum of x divided by n. So the sum of x is 27 divided by 4 is 27, and gives me a mean of 4 into 27 is 6.75. So 6.75 minus b, I've already calculated, that's a negative of 1.10. times the mean of x. So 4 plus 3 is sum of x, which is 10, divided by n, 4. 4 to 10 is 2.5. So 2.5. And so, make that calculation. Remember, we're subtracting, so we multiply these two, subtracting, change the sign of the subtracting. The addition column that gives you a negative, or gives you a 9.5, not negative, it's 9.5. 9.5. Well, I said that it's going to draw a line, and we'll draw that line specifically in a minute, that it would cross around 9 something. Here, you have to do arithmetically. I did it, use the formula of the mean of y minus b times the mean of x, and it's 9.5. So when you have 0 years of education, you're saying the person is making $9.50 an hour. The value of y, x is 0, in this case, is 9.5. You're making $9.50. You don't know why. Dollars per hour. 9.5 of it is $9.50 for 0 years of education. How many get out of class?
Wait. Where did you get 2.5?
The 2.5 is the mean on x. So x 4 plus 10 divided by 4 is 4 to 10, 2.5. 6.75 is mean on y. So we produced the two values that we need in class because we've not taken all together. We all know where B came from, we know what B means, we all know where A comes from, we know what A means. Those are the two parameters needed in the equation. But there are questions coming in what those mean. So now we take it to where our problem is. We're ready to answer our problem. We have our regression equation of y hat, the value y, is equal to 9.5 plus b was a negative 1.10. And I said, what if x is 1? If I said, what is the value of y when x is 10, how would you put it in? Any other than you want. Okay? So our problem was a 1. So plugging a 1 into it, we get negative 1.10 plus here. And it should be 8.1 hash. Right through here. What hat is equal to 9.5 minus 1 times the negative would be 8 point. What's that? It's funny, I count. 8 point. You're just subtracting practice. 9.5 subtract 8.4, I guess. Is that right? So I put this equation 1 times the negative 1.10, which is negative 1.10, plus 9.5, which is 3.4. Okay. So the answer to my question is what do we predict Y to be the next one? Is we predict Y to be 8.4. The person had 1 year of education. We're predicting their income to be $8.40. 8 plus 4 cents of another year would be $8. Everyone with me? Let's have a practice problem and make sure you can do it. No questions.
From the 8.4, what would we have to say? After 1 year of.
Or you're just asking me?
Yeah.
So I'm answering this question. I'm predicting that Y, which is the dollars per hour that they're making, is $8.40 if they have 1 year of education.
Okay.
Let's take a simple problem, something that we can move through pretty quickly. We could go with the data that you have that I gave you. You guys have the correlation on that practice problem I gave you the other day. I would like to use the data